So in this question, as you can see, in this we are having R also, L also and C also, right? And I told you, if we are having all the three element RLC, then it is known as second order RLC circuit, right? Okay, so now for this we have to follow the certain steps again as we did for the first order circuit. What was the step number 1 for first order circuit? We have to draw the circuit t equal to 0 minus, right? For t equal to 0 minus, that will behave as a steady state. Now in this case, as I told you, in steady state condition, inductor will behave as a short circuit, correct? And capacitor will behave as a open circuit, correct? This was the case. So at t equal to 0 minus, we should know the switch is closed or opened, right? So now tell me, at t equal to 0 minus, switch is closed or opened? Switch is closed, right? So I am closing the switch, right? This is for t equal to 0 minus. And capacitor will behave as a open circuit, right? And inductor will behave as a short circuit, correct? So the circuit diagram would be look like this. And in this we need to calculate I of 0 minus and V of 0 minus. I of 0 minus is the current across inductor. So the current flowing across inductor is I of 0 minus, and the voltage across capacitor is the V of 0 minus, right? So we can mark A point and B point. So now simply we have to calculate I of 0 minus. For this, tell me how many meshes are there? For calculation of I0 minus, 2 meshes. So we can say that this one is I1 or I of 0 minus, right? This one we can consider as I2. No, there are not 2 meshes because in this no current is flowing now. This is an open circuit. So there is only single mesh, right? So I of 0 minus is, yeah, it's an open circuit. So that is V by R. I is V by R. V is how much here? That is 12 volt, right? And resistance is how much here? That is 2 ohm. So can we say that 12 divided by 4 plus 2, 6, right? That is equal to 2 ampere. Okay, got it? Then we have to calculate V of 0 minus, means V of A and B, right? So we can write down C point here and D point. We can say that VAC plus VCD plus VDB, right? VAC is 0, VDB is also 0, VCD is how much? ICD multiplied by RCD, right? So ICD is how much? We got it 2 ampere. RCD is also 2 ampere. How much we got it? That is 4 volt. Okay, so I of 0 minus is equal to 2 ampere and V of 0 minus is equal to 4 volt. Got it? Clear?
Yes.
Now our step number 2 complete, and we got this value. First part, I of 0 minus at 0 minus and V of 0 minus. Clear? Now what is our second step? Step number 2, we have to calculate at t equal to 0 when the switch is in the transient condition, right? So again we have to draw the circuit. This is the circuit. Now tell me, at t equal to 0, switch is opened or closed?
It's going to be open.
It's going to be open. So I remove this 2 ohm, right? I can remove this 2 ohm if there is no role of this, right? So as you know that IL of 0 minus is equal to IL of 0 plus, right? So we can say that we are calculating at t equal to 0 plus. And you know this thing also, voltage across capacitor will also not change, right? Inductor current will not change and capacitor voltage will not change, right? So IL0 minus is equal to IL0 plus. IL0 minus we already calculated, that is 2 ampere. Voltage across capacitor we just calculated, right? That is how much we got it as 4 volt. Got it? Sorry, 4 volt, right? So we can say that VC of 0 minus is equal to VC of 0 plus is equal to 4 volt, right? And the IL of 0 minus is equal to IL of 0 plus, that is equal to 2 ampere, right? Now if we want to calculate, see in the question what we need to calculate, dV by dt, right? And you know the formula, IC is equal to how much? What is the formula for the current across capacitor? C dVc over dt. So we are taking for 0 minus. C value we already know, that is how much? 0.1, right? dV C by dt we need to calculate, and the current across capacitor we already calculated, that how much current is flowing across this wire, that is 2 ampere, right? So we can put it here 2 ampere. So we'll get 2 by 0.1 is dVc by dt. 2 by 0.1 is 20, right? And its unit is voltage per second, volts per second, because it is V by time now. So dVc by dt is 20 volts per second. So we got it, dV0 by dt, right, at time 0. Now what we need to calculate, we need to calculate di by dt, right? So tell me, how can we calculate di by dt? What is the formula? Voltage across inductor. Tell me, what is the formula for the voltage across inductor?
It's going to be L to the
L,
integration of
no, L di by dt, right? So can we apply KVL here in this particular thing? This is the voltage, total voltage must be equal to VR plus VL plus VC, right? Can we write down this statement? V is given already 12, right? VR is how much? I into R. VL is how much? L di by dt. And VC we already know, that is we already calculated 4 volt, right? So I we already know 2 into resistance we already know 4, right? Inductor we already know 0.25. Now which value we don't know, that is only di by dt. So after solving it, we'll calculate di by dt, that would be 0 ampere per second. Got it? So our second part is also done. In the next part we need to calculate V infinity and I infinity. So we have to draw the circuit at t equal to infinity, right? So at t equal to infinity, tell me, the switch is opened or closed? The switch is opened, right? So I can remove it. Now if the switch is open, no, at t equal to infinity, see the diagram. At t equal to 0 it was open, so at t equal to infinity also it will be open. Now it will remain, yeah, okay. Sorry, it will remain open, so there is no role of 2 ohm, right? The circuit would look like this. Now in this case we need to calculate current across inductor, that would be I infinity, and the voltage across infinity. As I told you, that t equal to infinity. This is the condition for the steady state, right? For the steady state, inductor will behave as a short circuit, correct? And capacitor will behave as a open circuit. So v, that is v infinity, right? So as you can see, if there is an open circuit, current will flow across through it, yes or no? Hmm? What would be the value of I infinity here? Yeah, it is an open circuit. 0. And V infinity would be equal to, we can mark it here again, VAB CD, right? So we can mark VAB is equal to VAC plus VCD plus VDB. VAC is how much? IAC multiplied by RAC. VCD is 12. VDB is 0. IAC is 0, as you know that no current will flow, right? So we can get the value of VAB is equal to 12 volt. So V infinity is how much? 12 volt. Okay, got it? Clear? Any doubt up to here? Now see, this is at transient. We have to consider at transient. Main like second order starts from here. For if it is a series circuit, you have to like learn the formula. If it is a series circuit, then value of alpha is R by 2L. Formula for alpha is R by 2L. And if for omega naught, the value of formula is omega naught is the frequency and alpha is the formula for this omega naught is 1 by root LC. Okay, as I told you, if alpha is greater than omega naught, then this is the case of overdamped. Okay, and for overdamped we have one equation for the current IT, that is A1 e raised to power S1t plus A2 e raised to power S2t. But for this we need S1 also. S1 is minus alpha plus root of alpha square minus omega naught square. S2 is minus alpha minus root of alpha square minus omega square. Okay, after getting it, we'll get the value of S1 and S2, then we can write it down. Now see, what is the role of this? Do we know the value of R here? Yes, we know the value of R, that is how much? 4 ohm, right? R is 4 ohm. Do we know the value of L? L we also know, that is 0.2 Henry, 0.25. And do we know the value of C? C also we know, that is 0.1 farad, right? This was the circuit. If I'll put it down the values here, then we need to calculate alpha is equal to R by 2L. R is 4, 2, L is 0.25, right? And similarly we'll calculate omega naught. Omega naught is 1 by root LC. 1 by root L is 0.25 multiplied by C is 0.1. If we'll solve it, then we'll get the value of, that is 8 radian per second, because, and for this we'll get 6.325 radian per second. Okay, now you have to tell me which one is greater, 8 or 6.3. 8 is greater than, so alpha is greater than, yeah. So if it is the case of series, I can mark it as S, alpha S, for alpha omega S. Okay, so this is the case of overdamped. And for overdamped, I told you the equation, that is I of t is equal to A1 e raised to power S1t plus a2 e raised to power s2t, right? S1 we need to calculate. S1 is minus alpha plus root of alpha square minus omega naught square. Alpha value we already calculated 8, omega value we already calculated 6.3, so that would be minus 8 plus, I'm just putting down the values, then we'll get the value of S1 as minus 3.101 and S2 is minus 12.8 something. Okay, now can we put it in this equation? A1 e raised to power minus 3.1 t plus a2 e raised to power minus 12.8 t. Got it? This is we got as a transient equation. Okay, but still we need a1 and a2 value, right? Still we need a1 and a2 value. So how can we find out a1 and a2 value? We have to learn some steps to find a1 and a2. Like what we got, it is equal to a1 e raised to power minus 3.101 t plus a2 e raised to power minus 12.8 t, right? So we are measuring at t equal to 0 always in the first step. At t equal to 0 means I of 0, a1, if we'll multiply t with the 0 then it raised to power 0, again a2 e raised to power 0, and anything raised to power 0 is 1, so a1 into 1 plus a2 into 1. I of 0 we have already calculated, right? I of 0 minus we have already calculated now, that we got as a 2 ampere. So simply we'll get 2 equal to a1 plus a2. This we got as a first equation. Okay, now we obviously need another equation to find out the value of a1 and a2 now. So our first step completed. Second step, we always calculated di by dt. Okay, like we have to differentiate that equation. It we got it as it is equal to a1 e raised to power minus 3.101 t plus a2 e raised to power minus 12.89 t, right? Now differentiate this equation in the step second for calculation of second equation. So if we'll differentiate, then that would be minus 3.101 a1, right, e raised to power minus 3.101 t plus then minus 12.89 a2 e raised to power minus 12.89. So we have to do it for at t equal to 0 again. Okay, at t equal to 0 means time is 0. So if time is 0, then minus 3.101 a e raised to power 0 plus I'm removing this plus and minus 12.89 a2 e raised to power 0, right? So that would be minus 3.101 a1 minus 12.899 a2. Di by dt again we already calculated above. That was how much? Di by dt we calculated above now. In this case that is 0 ampere per second. We got it. Okay, so di by dt is 0. Now we are having two equation. One equation is this one and another equation is this one. After solving it, we'll get the value of a1 and a2, right? A1 we got it as 2.633, a2 we got it as minus 0.633. Okay, so it would be equal to, as I told you, the equation a1 e raised to power s plus s1t plus a2 e raised to power s2t, right? So A1 we got it 2.633 e raised to power minus 2.101 t minus 0.633 e raised to power minus 12.899 t. This is we got it as a for the transient response. Okay, so this is our final answer for the current equation.